Hi, I'm Caden here with Kepler Electronics, and this is my 1-pound combat robot Stompbot. Let's go through how I made it. Stompbot was my first combat robot creation that I built, throwing some motors and a big defensive wedge on the front of an average guitar pedal enclosure. I took it to the Kilobots Canadian National Championships where it lost relatively quickly, but did show its strengths in some extra matches after it got knocked out. I decided to try and improve this design to make it even better. The first iteration had this relatively simple single bend wedge, along with this screw wrapped in tape to prevent the bot from wheeling over onto its head. The power switch required by the rules was held in by a mess of hot glue, and the power LED was simply the motor driver glued into place. It definitely wasn't pretty by any means, but I really enjoyed driving it and it was pretty fun to make. But all of these issues were things that I really wanted to fix. In this process, I ended up actually building not one, but 3 Stompbots. I made one wedge and enclosure setup on a whim earlier to test the drilling and bending but didn't film anything, and then ended up making another 2 sets to get some footage at different angles. Now, there is a bit of a stigma against building multiple robots as you don't really have to work on repair between matches. But honestly though, this is mostly a case of having too many parts, too much time during lockdown, and having a third transmitter that I accidentally bought for a different project. I also remembered that Steamed Hams, a bot that I had fought with the first iteration of Stompbot, had 3 independent bots, which proved really nice as loaners when the airlines lost some people's drum spinners and checked baggage. I know the builder of Steamed Hams, Brian, had planned on running them as a beetle weight for some grudge matches, but I don't think he was able to resurrect them all in time. Provided I can find enough friends to drive them all, I might try and run all 3 of them as a beetle called Battlebot or something at a competition. The one problem with this is that it'd be nearly impossible to tell them apart while driving, so that's why I decided to go with a paint job. To keep things relatively themed, I'm using the 3 colors for Blast Wave because they're pretty different for identification purposes, and I also have the spray paint cans here with me. On the plus side, it keeps things on the Outrun theme, which means I have pretty good reason to still use these stickers I was planning on using for the Create US Open Vex tournament, and it's obvious why that never happened. I painted all 3 sets at roughly the same time, 2 in boxes and a third on a sheet. Even though I set up the painting in my heated garage, I live in the Great White North and the paint did this strange congealing thing where it turned into a bit of a scaly texture. I decided to sand most of the parts back down and wait until it got a bit warmer. But let's go back in time a bit and actually take a look at how I built the wedge. The original wedge was just a single bend in a sheet of steel, and while that was relatively easy to make, it does allow horizontal spinners to kind of grab the edge and easily throw the bot. So in comes a new side bends, which will help guide horizontal blades up and over, which can still result in throwing of both bots, but should help me get thrown around a bit less than before. Now this was very difficult to make, but the process was relatively simple. I first made a model in Fusion 360, super roughly to try and get the geometry right. It was just a few plates, which I then rotated onto a single plane and extruded together. I printed this assembly out in PLA, which I then outlined on this sheet of 16 gauge steel. After cutting this out using an angle grinder, we then come to the difficult process of bending. Since I don't have an industrial sheet metal brake, I had to do this the old-fashioned way. Now this can be accomplished in 2 ways. Way 1 is to take a hammer and pound it to bend it. You can then go and do the same for the other side, then push it into a vise to push both ends together. Or the other way is to take advantage of leverage and simply use your hands to push the part into place. This is much more difficult when the piece is so small, but it doesn't damage the piece so much. This can also be made even more difficult when your workbench wants to move more than your piece, but it can produce some stunning results. With all the parts painted and the wedges bent, it's time to assemble things. First things first, I like to attach the wedge with a set of nylon lock nuts and 8/32 Allen screws. I'm using ball tip Allen keys to let me screw it in from this strange angle. To fix one of the issues I outlined earlier, I wanted to improve the aesthetics of the bot by using a beveled LED holder instead of a simple hole. These are used in a lot of guitar pedals and helped out a lot with making it feel more like a true pedal. The only problem here was that the bezels I bought are for some reason way too long for my enclosures, so I had to pull out the LED, cut them down to size, then glue a different LED with crimp connector ends into the hole. There's a locking washer and a nut to hold the bezel in place, which holds really well. The next major issue was the power switch. This whole thing was attached by massive globs of hot glue in the first iteration. Now this took up a lot of space, wasted a lot of weight, and could break free in the torque of turning it on. I was tired of these problems, so I decided to screw the FingerTech power switch in. The only screws I had on hand that threaded into the holes were just a bit too long, so I ended up using a few washers here. If I need just a couple more grams of weight, I could probably get it from here if I wanted to. Soldered to the power switch is the Endbot's DESC speed controller, which helps control the motors and do a little bit of mixing for the controls. Now, the washers are super important for a different reason, because without them, the screw ends would just run into the motors, as the motors run pretty close to the switch. I wanted to move them as far back as possible to help prevent the bot from tipping back when it drives forward, as there would be more weight in front of the motors. The motors themselves are basically the same thing as before, simple 20mm gear motors with JST connectors for easier replaceability. I might go for the battle hardening procedure with some Loctite, but since I was able to run the last set of motors in 6 matches straight with no problems, I can probably skip it. Connected to the DESC are the motors, but also the receiver. Same as last time, it's powered by the DESC's built-in battery eliminator circuit, but each bot type has a different receiver. The teal bot has the Lemon RX receiver, the navy one has the Fly Sky, and the pink one has the Futaba. Each of these pairs to a different transmitter so they can all be independently driven. The wires are all attached in the same way to standardize driving across the different bots, and the LED is also attached here for ease of wiring. The next big change was the battery. The battery in the original was this Horizon Hobby 400 mAh 2S battery, which was way overkill. It only needs to run for a little over 3 minutes in a normal match and maybe 5 or 6 minutes in a melee, but I use this bot for some robotics outreach events and it would run for somewhere between 20 and 30 minutes between charges, which meant that I could cut it down a lot to save weight. This new battery is the Galaxy 120 mAh battery, which comes in at about 17 grams lighter, which is about half the size. In testing, it can run for well over 5 minutes, more than enough for a single match, and good enough for most Rumble matches. The wheels and hubs are both the same type as the first go-around, the bot kit's wheels for their D2 kit. Thick, heavy wheels that are a bit cantilevered and don't touch the ground, so they don't really need to be this big, but it just wouldn't be StompBot without them at this point. After buttoning the bots back up, it was time to weigh them. These are ant weight class bots, which means that they need to weigh less than 1 pound, about 453 grams. The teal one was the first one finished and came in at a chill 17 grams under. The pink one came in at 2.5 grams under, and the navy one came in at a comfortable 10 grams under. I was actually quite worried about weight, but they all managed to come in under the weight limit, albeit pretty close in terms of the pink one. I think the massive variance in weight is due to differences in the wedge mounting plate. Each of them had a slightly differently cut mounting plate, which had different amounts of material around the screw holes. As I get accustomed to drive around with the bots, I might see if I really need a wheelie bar or if magnets might help out a bit. And I'll definitely need to cut out some more weight for them, but I'll probably cover that once they get closer to an actual tournament. Here's hoping that things start looking up soon so we can start competing again. I hope you enjoyed this video, and if you enjoyed it, you might also like checking out my video on the CAD of Blastwave, which is a bit more involved on the CAD side of things. If you want to check out the first competition StompBot went to, that will be linked in the description. Be sure to follow the link down below to check out the Instagram page where I've been teasing upcoming projects. Thanks for watching, and goodbye.